In this video, we're going to look at the sum of nth terms of a GP. So if a geometric progression is given as A, which is first term, AR second term, AR2 third term, AR3 fourth term, all the way down to ARn minus 1, which is the nth term, then the geometric series is obtained by adding the terms as follows. So remember when I treated a series of n terms of an arithmetic progression, I told you that a series is when the terms that make up a particular sequence or a particular AP or GP are added together or added to each other. So once there is addition, that is no longer a sequence, it's a series. But if there's no addition, it's only a sequence. So then the geometric series is obtained by adding these terms as follows. So A plus AR plus AR2 plus AR3 plus down to ARn minus 1. This presence of this addition makes the sequence a series. So the sum Sn of a GP can be found as follows. So Sn is equal to A plus as first term plus second term plus third term plus fourth term all the way down to the nth term, which is the last term that makes up the sequence of the series. So multiply both sides of equation 1. This is equation 1. Multiply both sides of equation 1 by r. So you're going to have r Sn equal to AR plus AR2 plus AR3 plus AR4 plus ARn minus 1 plus ARn, which is the nth term. Then if you subtract equation 2 from equation 1, you're going to obtain Sn minus Rsn equal to A minus ARn. Then you factor Sn out. So this will give us 1 minus R and close in brackets equal to A minus AR raised to power n. Therefore, the sum of the nth term of nth terms of a GP is equal to A minus AR raised to power n divided by 1 minus R. So this gives us equation 3. But if we subtract equation 1 from equation 2 or multiply both the numerator and the denominator of equation 3, which is this, by minus 1, we're going to have Sn is equal to E brackets open Rn R raised to power n minus 1 over R minus 1. So these are the two formulas for this and this. These are the two formulas for calculating the sum of nth terms of a GP. So whichever formula you're going to use depends on the denominator, depends on R, which is a common ratio. So note that either or the above formula can be used provided the one you use gives a positive denominator. Thus, if R is less than 1, maybe 3 over 2, 1 over 2, 1 over 3, if it's less than 1, use formula 3. When R is less than 1, use this formula because you want to have a positive denominator, not a negative denominator. If R is greater than 1 and you use this formula, you're going to have a negative denominator, which is not supposed to be. So in that case, you are going to use this formula. So if R is less than 1, use this formula. But on the other hand, if R is greater than 1, then use formula 4, which is this formula. So altogether, these are the two formulas for looking for the nth terms of a GP, which means the sum of GP, a series, and whichever formula you're going to use depends on the denominator. So like I said earlier, if R is less than 1, use formula 3, but if R is greater than 1, use formula 4.